So as we can see, this pen is a stylus. So without wasting time, we have a stylus. It is a digital pointing tool. Number 33, a digital pen. This one converts handwriting to digital form. So let's say if I write here, this is converted from my handwriting to the digital form, meaning to say using the computer. So this digital form is what we mean by that. So it converts handwriting to digital form. Then when we look at our 34, handwriting recognition software. So just as the name entails, we have handwriting recognition software. So this converts your handwriting into a text. Like let's say for example, you write the word there. Then this there from your handwriting, it shall be converted to a text, which is the language that the computer writes, or rather how the computer writes, like that. From that to a text that looks like this format, to a text that looks like any of these used. You write the word used, then what appears is this. You write the word pad like that, the word that appears is that. So that is as a result of the handwriting recognition software. When we look at our 35, signature pad is used for, this is simple, it is used for capturing signature. Like for example, this is the one that they use to sign. Like for example, you have something like this, so SM like that. So this is a signature, so it is used to capture signature. When we look at this other one, graphics tablet is also known as, so a graphics tablet is a digitizer, so it makes things to be digital, pictures to be digital, so it is called a digitizer. Then when we look at our 37, graphics tablets are used for, so those tablets are used for drawing. So just as we saw, do we have any? Okay, so this is a graphic drawing. 38, wearable devices mainly use. So wearable devices mainly use touch input. Like for example, when we are looking at an example of a wearable device, those devices that you can wear, you can have a smartwatch like that. So those are mostly use input. So by using this, we have a touch option and all that to do most of the things. As long as you can wear, that's what we mean by wearable devices. The navigation keys use what we are going to call gestures. Remember, gestures which are used to move in order to control the computer like that. So for this one, we have portable media players use. So portable media players also use touch inputs. The example that we might have is a phone, I would say. A smartphone uses smart input. So smart input such as the touch screen. So as you, let's say, press on your screen, you are able to receive something. Now the media aspect, portable media, meaning to say something that you can carry that plays, let's say, videos and audios. That is what we mean by portable audio. So what you can carry that can play videos and audios mostly use touch input. Then our 41, double tap is used to. So as you double tap, when you press somewhere twice, let's say on an application, what happens is that the application on the computer will now be open like that. So double tapping, when you tap again, you tap, so 1, 2, what that does is that it opens an application. Then when we look at our 42, drag action is used to. So drag action simply means to say you are moving something down like that, in that manner. So drag action simply moves items like that. So that is what we call drag action, like that. So therefore drag action moves items. Our 43, we have swipe gesture is used to. So as you swipe, swiping like this, what it does is that it scrolls. So as you can see, I am scrolling like that. So swipe action in that context scrolls. So even as we speak right now, I'm still scrolling. So that's the answer for question 43. 43, where's 43? 43 is if we are going to have scroll. Then our 44, we have press and hold is used to. So as you can see, when I press and hold, so when I press and hold, what happens is that I'll get more like a menu like that. So what press and hold does is that it is used to open menus. Without wasting now time, 45, touch input is common in, we have the smartphones there. Our 46, we have voice input uses. So when you want to more like voice input, what it captures is sound using a microphone. So you will use a microphone for the voice input. And then our 47, we have voice recognition converts. So when you are searching, let's say on Google, when you go on the option for just talking where you want to search for something, then when you say how, it will say how. So it converts speech to text. You say how are you, this is what happens, like that. Then we move on to our 48. Audio input includes. So audio input includes, so audio has to do with sound. So webcam, so the web aspect has to do with recording live. Then we have camera, it has to do with the video, so it is used in capturing videos, so live videos for that matter. Our number 50 is video input captures. So if you are looking at an image, so video is just a motion of images. Like let's say for example, if I draw this, I can make this person to be able to move, so like that. So therefore video is just motion of images. When we look at our 51, motion inputs uses, then motion inputs involves the gestures. So gestures can be hand signs, how is your hand moving, how are your feet moving, so all those are gestures. So as you move your hands, as you move your feet, those are what we call to produce what motion. So that is basically what motion is. When we talk about air gestures, is we're just looking at moving body in the air. Then when we look at our 53, motion sensing devices detect movements. Very simple and straightforward. Motion, so motion has to do with movement. NFC, that's near field communication. Then we have NFC is used for, so this one is used for contactless transfers. So in the last video I gave an example of how this works. So it is used for very near, let's say you have, this is a door to a place that only workers can enter. Then it has a place for a card. It has a place for a card. So someone with a card can be able to enter this place by using that card, like that. To swipe here, when they swipe the cards there. So that type of access is granted by the near field communication, which uses radio waves. when we look at our next question, which is our 56, OCR stands for, we have optical character recognition. So the answer here is our A. So this optical character recognition is used to convert text into editable digital text. Like for example, if let's imagine to say this was paper. So let's say if this is paper, so if I capture this portion of the paper, I can then be able to, let's say if this is the paper, I capture this. When it scans, it is able to convert into this form where I can now transfer to the PC or rather to the computer, and be able to copy anything and edit anything like that. So that is the operation of the optical character recognition. So these characters, we are looking at these data, the numbers, it converts them to an editable form. Then when we look at our 57, so the OCR reads, which I believe we have already answered. OCR reads printed texts. So it reads printed text. So this reads characters that have been scanned from characters from scanned documents. So if you scan a document, if there is the word there on the document, it will be able to be transferred on the computer and be in the texted form like this. Then when we look at our OMR, so OMR is optical. We have optical mark recognition. So this recognition, this is very important technology. It is used to read marks. Like for example, if you're writing a test that is purely based on multiple choice, let's say you shade on your A, you shade, the answer here is B, the answer there is C. This is used to mark those full papers, unlike the lecturers marking themselves. The OMR, they just put in a machine, then it will be able to mark with the instructions. So that is the optical mark recognition. So it just looks at how is the shading. So if you shade like that, the machine is fed the information to say if you see something like this, that means to say that's where the answer is. If it's on the right place, you mark like that. Then when we look at our 59, barcode readers use, so if let's say this is the barcode, let's say there are numbers, there is a 3 here, there are different numbers, there's a 2, there's a 1 and all that. So this is the barcode. Let's say this is the barcode reader. So it emits lasers like that to be able to read. So a barcode will use lasers. Then when we look at our QR code, so this is an example that we might have. So this is a QR code. So it's a 2D thing. Then the barcode, this is what we have. So the barcode, this is where we use a lasers to scan. So this is our QR code, which is 2D. So the QR code, when you want to share certain information using, let's say, share it, you'll use the QR code. Sometimes if you want to connect to Wi-Fi, you may use the QR code. You just scan the QR code for that Wi-Fi and you will be connected like that. So the QR code is 2D. Then unlike for the barcode, that is just 1D like that. So the barcode, the QR code is 2D. Then when we look at RFID, that's radio frequency identification. This one uses, just as the name entails, radio frequency identification. ID is identification. Then our 62, mag strip readers read, this one, mag strip, so magnetic strip, reads magnetic strip. Then we have the MICR So for MICR, this is magnetic ink character recognition. So we have magnetic ink character recognition. So this is used in banking. So this is an example of an MICR code. So this code is made in such a way that it is able to be read by humans as well as a machine by putting numbers that are magnetic like that. So this is very, very important in banking. Let's move on to our next question. Our 64 says data collection devices are used in, so those devices are used in real-time environments, whereby it is very, very important for us to know what is exactly happening at each and every time. So the example that we have are traffic lights. So things like traffic lights, these are supposed to be captured in real time. Like for example, in other words, we mean to say just in the moment as they are happening. So data collection devices are used in real time. An example, we might have the traffic light. These have to be working consistently. Then when we look at our 65, digital video cameras record. So digital video cameras record. So just as the name entails, digital. Moving on to our next question, we have hard copy refers to. So hard copy means it is a printed output. It is something that you can see written on a paper. So that is what we call hard copy. So we might have hard copy like that. Then our 67, an inkjet printer uses, so it uses ink droplets. So if let's say we have a printer, let's imagine this is a printer, this is a paper, it sprays small dots of ink like that on the paper, then it shall be able to scan. If let's say this is the paper, it has dropped the ink, then it shall be able to copy the words using that ink. So an inkjet printer uses ink droplets. Number 69, a laser printer uses this one. A laser printer uses toner and laser. So I've explained this in another video. Should be unit 2 or 6. So we have the laser printer uses toner and laser like that. So where the toner is the powder, then the laser is a concentrated beam of light. So how it happens is that, let's say we have a paper that is here, then here let's imagine that this is where the toner is, which is more like just dried ink. So as the beam of light hits the paper like that, it attracts this powder to come there. Then as this powder comes here, it is pressed with heat. What else have we talked about? It is pressed together to produce a liquid that will be able to stick to the paper. So as it sticks to the paper like that, let me use a different color, it is able to copy the exact words that are there, the exact words. Therefore, it is able to now produce an image. So that's the working principle. When we look at our 70, we have a photo printer produces. This is very simple. It just produces high quality images because it's a photo printer. It produces high quality images. Then a 3D printer, on the other hand, creates objects. Actual 3D objects are created by the 3D printer. So things like, let's say a modern cup can be created using a 3D printer like that, using a machine. Then when we look at our 72, thermal printers use, thermal has to do with heat. A plotter is used for, so a plotter is used in making very large drawings and also making maps, blueprints, and engineering designs. So this is an example of an image or a drawing produced by a plotter. It is very big, just as you can see. So this printer works by striking ribbon. So it's impact, so it has to strike. So like for example, let's say if this is the paper, then we have a ink ribbon, and a ink ribbon might be containing some ink like that. Let's say it contains some ink inside like that. So what happens is that the printer will hit against this ink ribbon, then it shall be able to more like melt onto the paper, thereby copying. So that is the working principle of the impact printer. So it works by striking ribbon. Then 75, a display device shows. So a display device shows visual output. So display has to do with the visual aspect of the videos. So let's look at our 76. We have LCD stands for liquid crystal display. This is the technology that is used in TVs. These new TVs use LCD type of a screen like that. Though right now what has been mostly used is LED, which is the light emitting diode. When we look at LED displays using, so LED stands for light emitting diode, and that's the answer. Then resolution refers to the number of pixels. So the number of pixels, we are looking at the number of colors that are present like that. So those are pixels. A pixel is a color like that. So we might have something like that. So the number of pixels determines the clarity, which is resolution. Resolution is the clarity number one, which is very important. It is how close the number of pixels are. So if there are a lot, they will be more like this. If they are not a lot, on the other hand, they will be separated, which we don't want. Let's imagine that, though this is not how it looks, but let's imagine that this is the person like that. Then a pixel is a color. That means to say if there are let's say pixels here, it will be able to split the person. On one side there will be black, on the other side there will be white and all that. So it is very important for you to know that the resolution is just or rather refers to the number of pixels. So a pixel is a color like that. Then we have the final question, which is brightness is measured in. Brightness is measured in. So brightness is measured in nits. Last but not the least, a data projector is used in. So this one is a display large images. So it displays large images. Thank you very much for watching. Hope you would like, subscribe and share for more. See you in the next tutorial.